Please take a seat.
Let us. Sir, I have a question for you.
Go on.
How did the solar nebular hypothesis begin?
So, solar nebula was made by Immanuel Kant, Emmanuel Swedenborg, and Pierre Simon Laplace.
And then, how
And
did
then-
it start?
So, it started with two gas clouds, and there was a supernova star. And because of that supernova star exploded.
And then,
And because of that supernova star, because of the explosion of supernova star, it created a wave or an impact that made the two gas clouds collide. And that's after the two gas clouds collided,
after it collided.
the particles are running everywhere.
So it's like that.
Yeah. So after the two gas clouds collide, the particles just go around there,
And then,
they got pulled back in. It is because of the gravity. So the gravity is in the center. So after they got pulled back in, there was a tremendous speed.
and then,
And that is the creation of the solar nebula.
So after the solar nebula was formed, it was still spinning rapidly.
Yes.
But eventually, it eventually slowed down.
Yes, you're correct.
So while it was spinning, I'm assuming that all the mass was pulled to the center.
Yes.
And with everything being in the center, I imagine that would be very dense and hot.
Yes, you're right.
So that would eventually create the sun we know.
Yes. Yes, correct.
So when there was already a sun, it continued to spin, and its rotation eventually caused the remaining matter to form clumps.
Yes.
And those clumps grew bigger and bigger, which eventually formed the planets, the asteroid belt, and other heavenly bodies in our
Yes.
solar system.
Also the moon.
Okay. Okay, sir. Thank you, sir.
Thank you.
Thank you for your
Thank you
time.
for your time.
During the solar nebula hypothesis, the formation of planets occurred through a sequence of events within a large cloud of gas and dust known as the solar nebula. So here is a summarized explanation of how the planets formed. First is the nebula's formation. A massive cloud of gas and dust composed mostly of hydrogen and helium formed as a result of the gravitational collapse of a molecular cloud in space. 2. Collapse and disk formation. The nebula began to collapse under its own gravity, causing it to spin faster and flatten into a disc-shaped structure called the protoplanetary disk. This disk contained most of the mass of the nebula. Number 3. Accretion. Within the protoplanetary disk, small dust particles collided and stuck together, gradually growing in size. This process is called accretion. Over time, these particles formed planetesimals, which were larger bodies ranging from a few kilometers to several hundred kilometers in size. Number 4. Planetesimal accretion. Through mutual gravitational attraction, planetesimals continued colliding and merging, contributing to the growth of protoplanets. Protoplanets are larger bodies ranging from the size of the moon to several times the Earth's mass. Number 5. Planetary formation. Over millions of years, protoplanets continued to accrete more planetesimals and mass. Eventually, some protoplanets grew large enough to clear their orbit or of other debris, becoming planets. This process, known as planetary formation, led to the eventual establishment of the 8 planets in our solar system. 6. And the final stage. After planet formation, the remaining gas and dust in the protoplanetary disk either dissipated or was captured by the planet's gravitational pull. This marked the final stages of the solar system's formation.
It's important to note that the solar nebula hypothesis is our current understanding of planetary formation based on scientific observations and simulations. While it provides a general framework, there are still some unanswered questions and ongoing research to further refine our understanding of the precise details of how planets form.
The Sun is a 4.5 billion year old yellow dwarf star, a hot glowing ball of hydrogen and helium. At the center of our solar system, without the Sun's energy, life as we know it could not exist in our home.
Mercury is the first planet from the Sun and the smallest planet in the solar system. It is a terrestrial planet with a heavily cratered surface due to the overlapping impact events.
Venus is one of the 4 terrestrial planets in the solar system, meaning that it is a rocky body like Earth. It is similar to Earth in size and mass, and is often described as Earth's sister or twin.
The Earth and its system. Earth is the 3rd planet in the solar system and is part of the terrestrial planets.
Mars is the 4th planet from the Sun. It is also called a round planet because of its rugged appearance due to its iron-rich, basaltic surface covered in dust and iron oxide. Its thin atmosphere is mainly composed of carbon dioxide with traces of nitrogen, carbon, oxygen, and water vapor.
We have the largest planet in our solar system, the Jupiter. It is so big that more than 1,300 Earth would fit inside it.
Saturn is the second to the largest planet in our solar system. It belongs in Jovian planet because of its fast rotation and slow revolution. It rotates clockwise and it makes a complete orbit in around 29.4 Earth years or 10,756 Earth days.
Uranus is the 3rd largest planet in the solar system, and it is the 7th planet out from the Sun. Uranus is made up of water, methane, and ammonia fluids. The core of the Uranus is thought to contain icy materials. Uranus gets its blue-green color from the methane gas in the atmosphere.
Interesting fact about Neptune is that it rains diamonds. How is that? Well, hydrogen and carbon from the interior are slowly squeezed because of the high pressure as it forms solid diamonds and continues to sink further down into the interior. Now, I would say pack your bags and let's go live to Neptune.